Testing. Okay. And my apologies, we are just a couple minutes late. Okay, and we're a couple minutes late getting started. Hello, everybody. Please respond in the Slack channel if you are with us this evening here in the EU. Daytime for those of you who are in the US, and we'll get started. Okay, sounds good. Okay, well, it looks like Jamie has found the link. Thank you. Thank you to the ingestion engineer. Use the link Jamie has posted. Yeah, thanks for the save, Dan. Today we're here and have and are ready for lecture 1. Okay, so well, nuts. All right. Okay, so should we also be somewhere in the sim? No, feel free to be in the sim at the moment, but I have nothing going on there from my end. So this is Prolog, and Prolog is a query language. A query language, you may already know, is SQL. In SQL, you send a query in SQL, and then you have database tables, and the SQL engine then processes your query and gives you a result. Prolog's a little bit similar in that you have a query which you pass in via the interactor, and the interactor is the the interactor is this character, the question mark minus, and this is where we can type a query in. So we can ask it, what are the members of the list A, B, C? And it will tell me A. And then it will sit here and blank, which means I might have more results for you. I might actually have more proofs of this. So B, and then C. So it can prove that there is indeed a member in the list ABC by naming 3 different ones. Okay, so that's the query, which is one part. The other part is that we have to have a knowledge base of rules. Some people say facts and rules, but facts are actually just rules that are whose body is true. Don't think so. Oh, that was in regard to the OpenSim. So we're going to have this knowledge base. Now, where does that stuff come from? Well, the primary place it comes from is your Prolog source file. However, Prolog is not defined in terms of its source file format. It is defined in terms of its internal data structure process called homoiconicity. So the Prolog source file gets read in by a process called consultation. Don't worry if you say you're loading your file or compiling, because those are probably words we would use today, but at the time they called it consultation, and it is in fact somewhat a different process. The other place you can, the other way you can add things to the knowledge base is that there's actually a predicate to do it. There's a built-in system call. I can say assert I am on YouTube, and then I can find out that I am indeed on YouTube. So these are the big pieces of Prolog. That's that piece of it. Do we have questions about this? If so, there's a 10-second delay on the video. So there's a 10-second delay on the video, so if you will, so be aware when I ask a question, I will wait about 10 seconds for people to respond. Okay, so far so good. Good. All right. I'm going to get out of Prolog. This is just the normal bash shell. And when I start, I am going, I hope that's on the screen. When I start, I am going to use the name of the file after Sweet Prolog. If you are in Windows, you can actually just double click on the file in the normal sort of Windows way. If you're in Windows and you want to make a new Prolog file, you can just make a text file and rename it to .pl. How big a DB can the engine handle? Is there a way to dump what's asserted in the REPL into a file? There is no direct, like one call way to dump what's asserted, mostly because what's asserted is invariably your, it is effectively a way of having state. And it would not be normal to make code. For one thing, you're not going to have any variable names in what's dumped. Variable names actually go away in the consultation process. So it wouldn't be really useful to just have a one-time thing. There is, however, a very handy library that does much the same thing, called library record and library persistency. And you can say, hey, this stuff, I want this to be persisted to disk. Now, to answer your how big question, that depends on your own memory, but it's in the I've had knowledge bases with 50 million facts in them. There's this is like the question how many objects can a JVM handle? It's large, and generally, generally you would not want to dump what you asserted, because what you asserted probably isn't truly code. So you'd want to persist it in some more controlled way. Okay. That said, by the way, there are ways to inspect what's there. Okay, here we are, and Matthew. Yeah, there's clause, which will give you everything that exists in a given module space, actually. Okay, so we're going to start up, and I'm going to make it consult. Of course, we don't want to restart Sweet Prolog every time we make a change, so there's a few ways we can do this. We can type make, which will look for files that need to be consulted again, and if so, reconsult them. When we reconsult, we eliminate everything that was from that file before, and we then read the file in. There is a small editor, and you'll note I'm typing a period at the end of everything. And that small editor let's see, is everybody able to see this? Whoops. Whole screen gets to me. Okay. The small editor, if I make a change, I will put space in a comment. I can type Control S, Control C, Control M, and I've got a cool tool that somebody pointed out to show characters, but I'm only going to use those characters. So that's Control C, Control M, and that lets me just go ahead and update inside the database. What I want to do tonight is to demonstrate a simple program. This is a program that does one of these river crossing problems. In our river crossing problem, we have 3 adults, 2 children, and a dog, and we have a tiny boat that's only big enough for 1 child and 1 adult, or 2 children, or a child and a dog, and we need to get everyone across the river. So, as always in Prolog, we would start by saying go, and this would just print out the answer. And then if I type semicolon, I will get a different answer, and I assure you these answers are different. You can see there's slightly changing the strategy. Sweet Prolog contains a very nice excuse me, a very nice graphic debugger, and so there are a couple of ways I could start the debugger. I could taste tspy on go, or what I'm going to do now, and by the way, if you use tspy, the way to get rid of it is no spy. But I'm going to use gtrace, which simply invokes the debugger. And you can stick this in your code. So, a common debugging trick is, I know that somewhere below here I get in trouble. So, in particular, if Prolog is failing on you, you can make an extra clause that just calls gtrace. And then, if you ever reach that, you're right at the failure point. Okay, so this is Prologues debugger. I have queried, I have asked the question, give me a proof of gtrace and go. And so it will drop into the debugger and then attempt to prove go. And now I need my little tool. Okay. And now, when I use, I hit a space, and I drop into my program. So this is pretty much like a debugger in any other language. The important keys are space, which drops in, S, which jumps over, and R, which, since Prolog is just finding a solution, backs up and lets us retry, which is lovely because it means I can be sort of reckless in my debugging and S over things, and when one of them blows up on me, I hit retry and go ahead again. Is go a convention for the entry point? Honestly, there is no good convention. On that same subject, I should say that you can add -G Pilm if you can get the editor to launch. The debugger should launch. I'm not going to stop the lecture to debug that for you. Please see me after the lecture. So here we have our program, and I've hit space to get in. Now, if I hit space again, it will go into init. And the only way to prove init, since init's just a fact, I should say, by the way, here's what I'm doing tonight. I'm going to kind of step through this program, and there will be lots of stuff I have not covered in it, and but I wanted everybody to see a real program that was doing something, this is still a toy river crossing problem, but a real program, not just a family tree type thing. It always seems better to have at least seen what's going on in reality. Okay, so I hit space, which now notice that init, the only thing that can make init true is if its argument is left 3, 2, 1. I have two kinds of things to represent here. One is moves, and the other is the current state. So this is the current state. Current state is the start state for the problem. Left means that this thing is called a complex term or compound term, and this is so this is the local binding. All variables are local in Prolog. So this means this is a compound term, which is just kind of like a structure, like a C struct. And we have 3 adults, 2 children, and 1 dog on the left bank. And the numbers are always on the left, even if this says right, which would mean the boat is on the right. So, okay, if that was not too confusing. The other data structure we'll see is moves, which are going to be LR, and the numbers of adults, children, and dogs, or RL for left to right and right to left crossings of the stream. Okay, so the next thing we're going to do is say, is it true if we start with this one state that that there exists a plan? And it will say yes, and here's a plan. So for now, I'm going to step over with S, and you'll notice that I now have this large structure. By the way, if these structures get large, you're going to find that Prolog puts in a series of dots, and I will do it all after the lecture, but there's a thing you can put in your Prolog setup to tell it not to do that, because it can be annoying. Or, excuse me, or at least give it a more sensible limit. This is a set of moves, and presumably this gets you across the stream. I'm not going to check it. And then one more thing, which is right plan, and right plan is true if starting in this state and executing this plan is happy and has the side effect of printing the plan out. So, okay. Okay. And then, well, hey guys, this thing is interfering with my ability to run this thing. I'm going to kill this screen key deal. Now, with any luck, up. Okay, and now, nightmarishly, it won't. Okay, hopefully it went away. Oh, I'm not waiting. I am not waiting because I've gotten back here. That was what was the problem. Okay, so it gave me one solution, and it's going to give me the chance to write another one. Right plan says no, I don't want to write it again. So it backs up. All right, I'm going to restart. I'm going to hit R, and it'll print it here. I will get another solution, and this time I'm going to hit space and go in. Okay. Oh, I went into right plan. Look, guys, I'm going to hit L, which runs until I hit a breakpoint, and I'm going to restart this thing just because it's, I don't know where I got myself, but okay. So I've hit S to get across in it, and now we're going to drop into the plan. Now, the crossing plan gives me 3 rules for how to make a crossing of the river. How to make a crossing, how to make a whole crossing plan. The first is, if our initial state, and we're going to keep building the state up. Whatever's on the head is our current state, and everything else on the list is past states. But if our current state is that there is nothing on the left bank, nobody on the left bank, then we're done, and we can make the plan do nothing. If that's not true, then there's two cases. One for the left bank, with some number of adults, children, and dogs, and one for the right bank, with some number of adults, children, and dogs. And we will drop in, and the first thing that will happen is we're going to pick one of the moves that's possible. There aren't that many legal combinations of moves. We can go from the left to the right. Well, we were on the left bank, so they'll all be left to right. We could send an adult across, a child across, two children across, or a child and a dog. And member is going to be true when move is one of those four. So, of course, it's just going to give us the first one. Say, yeah, the first one is a member. Left to right with one adult. Now, one question. Is that a good move? Is that a good opening move in this game? Is anybody, have I bored everybody to tears and you've all left me? Hopefully not. No. I haven't bored you, or no? Okay, no, it's not a great move because the adult's going to go across, and then what's your next move? Well, you got to get the boat back, so the adult's going to have to row the boat back. Yeah, there's no one to come back. We don't want to be moving adults to the left. It's legal, but not good. Yes. Okay. So, but our computer's not as smart as we are, and we're going to try it. The next thing is, I've got this compound term, and I need to destructure it just because I need the three numbers out of it. So I'm going to make, so this line I just ran says, prove that move can be the same thing as LR with three variables. And it will say, yes, if the variables are boat A is 1, boat C is 0, and boat D is 0, which it does right up here. And then, so it happily did that. And the reason I did that is that we then have to make certain we have enough people on the left bank to execute this. And I'm going to hit S and get, we have enough adults, we have enough children, we have enough dogs on the left bank to do this. Okay. The next thing we have to do is figure out what the new state is. And, hey, and unsurprisingly, the new state is to simply subtract off the number of people in the boat from the number of people in the left bank, and move the boat to the right. So this is what's coming in. This is the move, and then it's going to say it's only true when this is going out. This is a process called unification. And unification lets us bind variables going both in and out. And we'll talk lots more about that this coming week. Somebody's asking a question, but I'll keep going until the question appears. So, we have a new state. Boat on the right. And Matthew, I see you typing. So, the next thing that was required is that we make progress. We don't want to move an adult over to the right and then move the adult back and then move the adult to the right and then move the adult back and never get anywhere. So we want to ensure that we are not in a state we got to go. Yes, thank you. I glossed over that. Yes, is performs arithmetic computation and nothing else does. So if you call foo with 1 plus 2, you get the compound term plus, with 2 arguments, 1 and 2, as in the thing you call. It's true. Yeah, Prolog simply unifies its arguments. It does not evaluate them. Okay, so here's my trick for making certain I'm not going in a loop. I'm going to keep track of where I've been, and I'm going to insist that the next move not move me back to where I've been before. So, okay, it fails. The new state is not in the list of old states. This, at the start, is negation. And so, so it says, which succeeds only if its argument fails. So prove that it fails. Prove that it is not true that the new state is a member of the old state, which is a verbose way of saying don't go in circles. Okay, and then we make a recursive call because we then need the rest of the crossing plan. And we drop in. And this time, notice that we went right to the last case because now the boat is on the right, so this one's not legal. This whole clause is not legal. We're not done. We don't have zeros in here, so this one's not legal. It won't match. So we're down here. Okay. So we're on the right bank. There's only 2 sane moves from the right bank. There are more legal moves, but it turns out they're never useful. Right? It's never useful to row an adult back. So I'm just not even going to consider those moves. I will only consider moving 1 child or 2 children back. No point moving the dog back. No point in moving adults back. So the structure is very similar. Right to left. Now I need the number of people on the right bank to check that I have enough people to do this. And so I'm going to take the total number of people that, total number of adults I've got and subtract off the number on the left bank, and that's the number on the right bank. And then I'll do the same with the children and the dog. Up. And notice what's happened here. I hit S a couple of times and I get down, and I don't have enough children to have 2 children row back after I've sent 1 adult across. Of course, there aren't any children on the right-hand bank yet. So this is called failure. Prolog's going to back up, going to backtrack. It's going to backtrack to the last place that I had one of these situations like here, where I where there were multiple solutions and it simply provided me one. This is called a choice point. Okay? And where is the last choice point? It's right here where I've marked. The last choice point is here where I decided to move two children across. So I'm going to hit S, and it'll return back up here, undoing the computation that it did since then. This is a very strange thing that it backs up and it undoes computation. I hit S, and notice this time I get one child rowing across. And of course, this is no more successful because I don't have any. Now, I have exhausted all of the possibilities for this member that I've been going back to. So it's going to go back to the one before it. And it will keep doing that until it finds something, until it finds a choice, all the way unwinding. And if it never finds another choice, it's going to unwind all the way back to the interactor, and it's going to tell me false. But here, if I hit space, notice that the stack got shorter. And by the way, notice that our stack display is a little odd looking because it's actually not a list as it would be in a language like C. It's a tree because we're in a search tree. So, okay, so it turns out that if you first move an adult over, you can never solve the problem. Of course, since I only allow for moving children from the right to the left. So I'm going to hit space, and it's going to back up, and this time it's going to back up to that first call to member, and it will try sending one child across. And this is going to be somewhat more successful. It's not, we have enough people to do it. We've computed the new state, which is going to be the right with 3 adults, a child, and a dog. This, of course, is actually not all that useful either because you know, an adult and a child is not in there. Oh, I know why. I was smart. There's no point in hauling a child and an adult. If you have an adult to row the boat with, do you need the child? No, but anyway, it's not in my list of moves. Okay. So, and so I hit space, I've stepped in. We're again going to try, nope, we don't have enough children to row the boat back. This time we do have enough children. And at this point, I am going to hit S. It's going to back up and try the next move of moving 2 children over. And this gets repetitive at some point, so I am going to simply hit S. Notice that we now have this big stack of choice points for member. This double-headed arrow is choice point. And that's because we made all these choices in the process of making this plan. So we have lots of choice points, and we have a crossing plan, and it's given us a plan. And there's our plan. I double-clicked on that. So there's our plan. And my apologies. By the way, if you want to avoid carpal tunnel, I highly recommend that program, but not while I'm streaming. And so we now have a successful crossing plan. Now we have to print it out. We'll step in, and the crossing plan starts with being on the left bank, so we're not going to say we're finished. We are going to, however, say that what was double-clicked? I wanted to show all of the large structure. What was double-clicked? I had a stream skip. What was shown was this. I double-clicked to get this little window open. It shows me all of a larger structure. So now, yeah, that was the plan binding. This is format. Instead of a percent sign, Prolog uses a tilde. And conveniently, Prolog knows the types of its variables, so you can say twiddle W, and Prolog will represent them in the appropriate way. And then this is just a recursive call, and it's not all that interesting. So I'm going to hit L. That's the L key, which will run until we either get back to the interactor or we hit another breakpoint. In this case, we got back to the interactor. It gave me it printed out a plan, and it's waiting to say, do you want to see other solutions? Do you want to see other proofs of this? We have and notice that this thing's still up. If I hit period and end the execution, then I've still got this window on the screen, but it's dead. You just close it. So, okay, that's a little run through of adults and children, which is in your folder for the lecture this week, and you can try it out. Questions about this? I guess I'll show you this clause. No, I'm not going to do that. Okay, so that's it. I went through a bit quickly, so I think I'm ready for questions, and after that we can go. Yeah, using the debugger is kind of fun, especially if you definitely try the R key, because it's really interesting to be able to back up. And I would point out you have to kind of overcome that conservatism that you learn when using a debugger. Um, Definitely, Piln. I encourage you to do that if you have some little Prolog program that does something that you think is cool. Just run it in the debugger and kind of let it run. A problem you will encounter, there are a couple of classes of Prolog bugs that the debugger has that you can kind of use the debugger to help with. One is infinite recursion. You will find yourself getting infinite recursion, and it will pause, and then it will warn you that you've run out of stack. Prolog does a depth first search. What does it do to avoid hitting the worst case combination of scenarios? Well, basically nothing. It hurts if you don't plan for the fact that your search space might be awful. Here we had to carry along a list of previous positions we'd been in, just so we didn't send the adult across and send the adult back and send the adult across and send the adult back. Send the adult. So you do have to plan for the fact that it's going to stupidly do a depth first search. Is that something you try to structure code to avoid? Predicate order. No, not particularly. It's part of the language. For example, when doing recursion, it soon becomes ingrained in you to put the base case first. So if you see me write recursion, even if the recursion would work in either order, you're gonna always see me put the base case first. So avoiding hitting the worst case combination of scenarios. No, I mean there are some techniques to get around that. You can do something called iterative deepening. That is, keep track of how deep you are. Prolog is pruning away parts of a solution space search tree. So a good algorithm trims away big chunks of that space as early as possible. So definitely if you have some big bushy search tree that's going to be computationally expensive, and then you need to guess one of 3 values, do your guessing of the 3 values right off the bat. Do that one first, because that way you only do that big search computation once instead of backtracking into it and stupidly repeating it 3 times. So but Piln, no. Okay, so I started to say something about debugger and got distracted by a question. The debugger is a good technique if you get this kind of infinite recursion is go into the debugger and then just hold down the space key, and it'll flash and what have you. But eventually it'll get to where it's doing something repetitive, usually some simple pattern. And when you see that, you can begin to understand what's going on. By the way, I'm going to show you one more debugger trick here, and that is I'm going to show you the holding down space key thing. Okay, I've got a bunch of stack here. Notice that it only prints a certain amount of stack. There's a couple of keys here to adjust it, but you can change frames. So you can click around in here and find out. That's actually the source code for the member function. or for the member predicate. And so we can find out where we are and move around the stack. So yeah, if you have something blowing up on you, just hold down the space key and you'll get pretty soon into some kind of simple recursion. The other trick is just go into your top level. The other category of bug that you get is unexpected failure. You'll write something nice and then you'll go into it and instead it'll just say false. So the cure for that is to use the graphic debugger and then just use the S key, go over all of the big pieces in a kind of unrestrained manner that you'd never do with a C debugger, and jump over things, and of course one of them will blow up. Will be red and fail when you weren't expecting that. And then you can just hit the R key, go back down to that one, and this time hit the space key when you get to it, drop into it, and then repeat the whole operation at that level and keep going down until you find out what's failing unexpectedly. Okay. All right. And okay. More questions. I see Pilm typing. That is pretty dang slick. Yeah. Prolog is, at first, feels like it's bizarrely constructed, but the longer I've worked with it, the more I've learned that it's the one right thing. You'll notice that the code has no indenting. That's because it has no control structures. All the code's just a list. Even internally, code is just stored as a fact, whose that's a compound term whose functor is the neck operator, and whose two arguments are the head and the body, and the body is just a linked list of compound terms with functor comma. That's all there is to the code. So this backtracking, strange as it may seem as a control structure at first, is very, very slick. Okay. And we'll wrap up if there are no more questions. Somebody had a problem getting the debugger to appear. Who was that? I said, Pilm, did you get your debugger to work? Cool. And yeah, Terry, very much. I want to emphasize to everybody, this was kind of the 10,000 foot view. You can't tell a comma from a period on YouTube. Oh, okay. All right. My apologies. Yeah. The code is in the week 1 assignment folder. In there, there's a lectures folder. Let me make certain. It's in week 1. It's in week 1 assignment folder. Yes. It's called Adults Children. Week 1. Okay. But yeah, Terry, don't be stressed that you're not uh, uh, getting everything yet. I wanted people to see a real program and get a sense of kind of how things go in Prolog, and then we'll start looking at the pieces in this coming week. Okay? And in fact, everybody's doing so good that as soon as I can manage to get it done, I'm going to start putting out material on Prolog syntax. Yay, everybody's Prolog newbie here, except those who aren't. But this is the class for the newbies, so yay, newbies. Yeah, Jacob. Yeah, is there a situation where the code sorted from a file is not logically sound, and which clauses are conflicting? Okay, this is I'm going to answer that question, but I should say that we're kind of at the end here, but I will. The adults children file is Prolog source code. When you consult it, you are when you consult it, you are reading it into the knowledge base. The knowledge base is an internal thing in RAM. Okay, back to Matthew's question. Is there a situation where it's not logically sound? Matthew, every clause is simply a statement of how something might be true. I have a brother, Randy. Randy is my brother because he is male and because my father is Don and his father is Don. That's one way of proving that Randy is my brother. But Randy is male, and his parent is Rosie, my mother, and my parent is Rosie, my mother, and so we have a second parent in common, and this means that there are two ways to prove this. Now, had my mother widowed or divorced and remarried, and then there might be only one way to prove that. But as a result, there aren't really conflicting clauses. Now, it may take an uncountably long time to get to that second clause, but you can't actually make clauses conflict. What does the reply say? Based on no, Patrick, there just aren't conflicting clauses because each one is a separate statement about the world. Okay, so you have A sub B. That second one is not a valid That second one is actually the statement that this is true, which is not particularly useful. It'll probably yell at you that you're not allowed to. No, actually, it'll tell you that you're not allowed to redefine the system not. And that would say, whatever else you do, this is true. No, negation is not allowed at the head of a clause. We only admit horn clauses. That's because the head of a clause is just the head of a clause is nothing but the thing that must match to use this clause. It's what unifies. Matthew, you've asked that in a couple of contexts, and hit me up sometime, and I will. And let's like on Slack or in the virtual world, we will sit and work together, and I will get through to the end of that with you, because I think that's an important thing to clear up for you. No, it's fine. It's fine. I just want to. I think I should end the recording at this point, and I'm happy to keep talking on Slack.